A modern aircraft carrier is nothing short of immense, measuring slightly more than 1,000 feet long and 250 feet wide, and weighing more than 90,000 tons. Two Westinghouse A4W nuclear reactors generate 550 megawatts of electricity, enough to run all of the onboard systems, fire the steam-powered catapults to launch the aircraft, and provide 260,000 shaft horsepower. Despite its vast size, a Nimitz-class boat moves quickly, achieving a top speed of 30 knots or 35 miles per hour. Technologies change rapidly, so the original equipment found on carriers, such as radars, weapons, catapults, anti-submarine warfare systems, and so on, needs attention after 25 years or so. A midlife maintenance action, known as a refueling and complex overhaul, or RCOH, takes about 4 years to complete and is a mix of repairs and replacements, bringing the ship's capabilities up to date and preparing it for the second half of its operational life. In March 2013, the USS Abraham Lincoln, hull designation CVN72, reported to Newport News Shipbuilding in Newport News, Virginia, for its complex midlife RCOH. In the past, ships were built from the bottom up. Today, shipbuilding is modular. Imagine the USS Abraham Lincoln being a 100,000-piece jigsaw puzzle. During the RCOH, you throw away half of the pieces, make 50,000 new pieces, then fit the new pieces to the old ones to make a half-new, half-old puzzle. When the process is finished, nearly every component on every system inside the ship will have been inspected and repaired, refurbished, or replaced. CVN72 will look the same on the outside, but it will be completely new on the inside. Most fabricators would be at home in the fabrication and machine shops at NNS. The various departments use machines for cutting, bending, welding, turning, and machining that are no different than you'd find in any other fabrication shop anywhere in the U.S. You might see a machine that requires manual setup once in a while, but nearly everything at NNS has CNC. Much more striking, of course, is how nearly everything at NNS is different from a fabrication shop. A key differentiator is the sheer scale of operations.
Here at Newport News Shipbuilding, we receive raw steel and shape from steel mills, and then we convert those into parts that we use to make nuclear-powered submarines and aircraft carriers. So the very first shop is about 300,000 square feet, very large, and inside that we take the shapes, T-bars, I-beams, structural pipes, square tubing, and plates of varying thicknesses, and we convert those into piece parts that then we can send to my other shops and actually make bulkheads and erect into units and assemblies and then start building the ship. If you look back there, that's a 2,000-ton press, and it can roll something that's up to almost 54 feet wide. Our Unison machine is a 8-inch machine. It is currently the largest electric bending machine in the world. We bend up to and including 8-inch pipe. Previous to this, that was all a manual operation for these sizes of pipe.
Nearly every assembly has a handful of gussets, brackets, braces, or reinforcements of some sort. The strength and weight of the components is mind-boggling when compared to items used in off-road automotive or even heavy machinery, as is all the work that goes into the components. But considering the application, it's easy to understand why.
This is a ballistic door for CVN-79, the second Ford-class aircraft carrier named the John F. Kennedy. The ballistic door protects personnel from blasts. These doors are very sturdy and they consist of multiple metals. We've got 4 different filler metals that adhere the parts in one of these doors. The engineers have done a careful balance of where crest, where mild steel, where high-strength steel provides the most protection for the sailors. Battling weld distortion is one of the issues we come with. They developed a weld spike and a simple turnbuckle. They've got edges they call a knife edge. They'll put this, slide this over the knife edge, apply tension, so when it's welded, it doesn't pull. The knife edge fits right into the channel, and they can adjust tension as needed.
Quite a bit of activity revolves around the Structural Fabrication and Assembly Division, or SFA. The SFA cuts and forms plates and structural parts for new construction, repair, and recos. When starting a project, the SFA's first activity is flame on steel, referring to the first burst of plasma that sets the project into motion.
So the first thing I want to point out to you is what we call the web line. And what we're making over here is bulkheads. This is like the basic Lego building block of a ship, where we're taking a flat plate and we're putting stiffeners on there and we're welding it to give it structural strength. Over here we have 2 robot gantries. The first one has 2 robots on it, and it welds all the horizontal welds of putting those stiffeners on the plate. The other blue gantry has another robot specially designed for vertical welds. So automatically they go down and sense where they are, they weld automatically, and then we'll do some additional fabrication over here before we're ready to ship them to the customers. So we're taking the parts we made in the fab shop that we're just in, and we're bringing them in here, large plates and shapes, I-beams and T-bars and things like that, and we're starting to put them together on automated panel lines. And these will form those fundamental walls and decks of a ship. And from here, we're gonna start to make units out of them, box units and very complicated units, and from there we actually start erecting the units and making the ship.
During peak operations, there were nearly 5,000 people working on the RICO. That's a combination of sailors, Huntington Ingalls staff, and outside contractors. When the RICO is completed during the 4 years CVN72 is in port, it will total about 23 million man-hours in the shipyard, 2 million man-hours on the ship, and 1 million man-hours in customer contractor teams. Shipbuilder Collis Potter Huntington made a commitment to the U.S. Navy when he said, "We shall build good ships here, at a profit if we can, at a loss if we must, but always good ships." The pride and experience of the employees at NNS are testimony that these are good boats, and the sailors deploy with confidence that they are on board 10 of the most fearsome and durable fighting machines ever built. The NNS team includes 40 shipbuilders with more than 50 years' experience, and every employee is guided by a second motto as powerful as Huntington's words about building good ships. It is my intention, and that of my fellow shipbuilders, to never send our sailors into a fair fight.